In this presentation, we have talked about Ehrenfest theorem. Before enter into this topic, Ehrenfest theorem, you should know some basic information regarding the dual nature of matter. According to de Broglie, a particle is in motion. A single wave is associated with the motion of the particle called de Broglie wave or matter wave. But if you calculate the de Broglie wave velocity, which is always greater than light, we know that de Broglie wavelength lambda equal to h by mv. This is equal to h by p. If you calculate the velocity of the de Broglie wave, v suffix d is equal to nu into lambda. Here E equal to h nu, energy of the photon, and according to Einstein mass energy relation, E equal to mc square. From these two equations, nu equal to mc square by h. Then de Broglie wave velocity Vd equal to mc square by h into, instead of lambda we have to put h by mv, which is equal to c square by v, which means that de Broglie waves are moving with velocity greater than the velocity of light, which is not possible. So we won't accept the de Broglie concept. According to de Broglie, a single particle motion is expressed in terms of a single wave. If we calculate the velocity of the de Broglie wave, which is greater than the velocity of light, because Vd equal to c square divided by v, here c square is the square of the velocity, v equal to velocity of the particle. This is not acceptable one. In quantum mechanics, single particle motion is expressed in terms of wave packet rather than a single wave. Say this is a wave packet which contains a number of waves. These waves are producing constructive as well as destructive interference. Finally, the entire wave packet may move with one velocity called as group velocity. See, the individual waves are having particular velocities. Finally, the entire wave packet may move with one particular velocity, that is called as group velocity. Group velocity equal to particle velocity. Say, the particle is likely to be present where the amplitude of the wave function is having its maximum value. Say the particle is likely to be present here or here or here, because these places are having maximum amplitude. There is no probability for the particle to present here or here, because the amplitude is very small at these regions. So that in quantum mechanics, a single particle motion is expressed in terms of wave packet rather than a single wave. But according to de Broglie, the single particle motion is expressed in terms of a wave alone. Now, we should know the meaning of the word expectation value or most probable value. Say position, momentum, these are all called dynamical variables. Suppose a particle is in motion, we have to concentrate on these variables, position, momentum and so on. If you want to measure position, to measure the position we are making so many trials. Among the n number of trials, we can get a particular result in most of the times. That value is called most probable value or expectation value. See here, among the so many measurements we made on a single dynamical variable, most of the times we usually get a particular result called most probable value or expectation value. Now, Ehrenfest theorem points out that the result of quantum mechanics is identical with the result of classical mechanics if you study the dynamical variable associated with the wave packet in terms of expectation value. That is a statement I have given here. Ehrenfest theorem states that quantum mechanics yields the same result as classical mechanics for the motion of a wave packet associated with a moving particle if we use our average or expectation value of dynamical quantities involved. See, this is the wave packet. Single particle motion is expressed in terms of wave packet rather than a single wave. Wave packet contains n number of waves. All the waves are producing constructive as well as destructive interference. Finally, the entire wave packet may move with one particular velocity called as group velocity. Then the velocity of the particle is equal to group velocity. Inside the wave packet, somewhere else the particle is located. The location of the particle is identified by observing where the amplitude of the wave function is having its maximum value. So the particle is present somewhere here, not here or here. Now the expectation value of position, x is position. Position is a dynamically variable. That means a quantity which is varying with time. Suppose a particle is in motion, that is called a dynamically variable. A person is starting his journey from point A to point B. Say at t equal to 0, the person is present here. After 10 minutes, the position of the person is here. We assume like that. This is a dash. So with respect to time, the position is changed. This is called variation of position with the time. If you want to calculate expectation value, this is called the dynamic variable. The expectation value of position is, we have to place position in this symbol. This is bra, this is kit. This notation is specifying average value. And then x equal to integral of psi star. This is complex conjugate of the wave function, because we are dealing with the wave packet. The wave is having some amplitude, that is wave amplitude is called as wave function. Put the complex conjugate value of the wave function and place the value of the dynamic operator here. The operator related to position is x, so that you have placed x as such. Then the normal wave function into dx whole divided by psi star psi into dx. Suppose the wave function is normalized, the value of psi star psi dx equal to 1. Therefore, the expectation value of position is psi star x psi into dx. If you want to calculate the expectation value of energy, see here, expectation of energy equal to, put the complex conjugate of the function psi star, then energy operator is IH cross dou by dou t. This is energy operator into psi and dx. If it is one dimensional, all divided by psi star psi d tau. Put this one also d tau, three-dimensional aspect d tau. This is the expectation value of energy. If the wave function is normalized, we can write expectation of E equal to psi star IH cross dou by dou t psi into d tau. No need to introduce this term. Here the energy operator value is IH cross dou by dou t. The position operator value is x, so that I have placed x here. So the expectation value or average value of position is complex conjugate of the wave function and the operator value and the wave function value into dx. If it is one dimensional, we can write dx. If it is three dimensional, we can write d tau. Now, rate of change of this position is d by dt of x, average value of x. Now we have to keep x as a constant. S will not vary with the time, and differentiate the quantities psi star and psi. Keep psi star x as a constant at the initial stage and differentiate psi. UV formula I have used, dou psi by dou t, plus keep x and psi constant terms and differentiate psi star, dou psi star by dou t into dx. This is the value of d by dt of expectation of x. Now in this relation, we have to substitute the value of dou psi by dou t and dou psi star by dou t. For that, we should consider the Schrodinger time dependent equation, h is psi equal to E psi. Here h is our Hamiltonian operator, E is the energy operator. If you express E in terms of operator, this is called time dependent. If you consider E as a total energy, mere a constant number. We can call this one as a Schrodinger time independent wave equation. Here E is replaced by the operator IH cross dou by dou t. This is the energy operator value. Energy operator value is IH cross dou by dou t. Now the Hamiltonian operator value is minus h cross square by 2m del square plus v. This is the way of arriving this Hamiltonian operator. H equal to T plus V. T is kinetic energy, V is the potential energy. The summation of kinetic and potential energy is called Hamiltonian. In Hindu mythology, we are having Ardhanarishwara, who is the Hamiltonian. Half of the part is Shakti and another one part is Shiva. Kinetic energy is Shakti, potential energy is Lord Shiva. So Ardhanarishwara is the Hamiltonian. Kinetic energy plus potential energy. Then kinetic energy of the particle is known to you, that is half mv square. Potential energy is V. Now this is modified as m square v square by 2m. Multiply the numerator by m, divide the above by m. So that we know that P equal to mv. This is P square divided by 2m plus V is the Hamiltonian. The momentum operator value is P equal to minus IH cross delta. Or this is modified as h cross by I into delta. That is also correct. Instead of this we can write R h cross by I into delta. This is momentum operator. If you want to calculate the x component of momentum, Px equal to h cross by I into dou by dou x. This is x component of momentum. If you want to write y component of momentum, Py equal to h cross by I dou by dou I. Then z component of momentum is h cross by dou by dou z. This is also modified as minus I h cross dou by dou x. That is also x component of momentum. Now substitute the value of Hamiltonian. See here P equal to minus I h cross delta. Then this is P square. Instead of P square you have to make the square. Here minus square plus I square is equal to minus 1. So this is written as minus h cross square by 2m del square plus v. Here minus square plus, but I square is equal to minus 1. So minus h cross square del square divided by 2m plus v is the value of Hamiltonian. Now instead of this h you have to put this value minus h cross square by 2m del square plus v. Then that is multiplied by psi. Here the energy operator is I h cross dou by dou t into psi. Here del square is three-dimensional operator. The value is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. The Schrodinger time dependent equation in one-dimensional form is you have to take the x component alone minus h cross square by 2m dou square by dou x square, one-dimensional, which means that the values of y and z are 0. So the Schrodinger time dependent equation in one-dimensional form is minus h cross square by 2m dou square by dou x square plus v into psi equal to I h cross dou psi by dou t. Our aim is to know the value of dou psi by dou t. Then dou psi by dou t equal to 1 by I h cross into these quantities. Now allow this 1 by h cross to operate on this minus h cross square divided by 2 h cross im dou square psi by dou x square plus v psi divided by I h cross. Then multiply the numerator by I, then denominator also by I. We know that I square is equal to minus 1, so minus into minus plus. This is I h cross by 2m. This h cross and h cross get cancelled. One h cross, this h cross cancelled out. So we are having h cross. Multiply the numerator by I, you can get I h cross. Denominator by I means I square minus 1, so minus into minus plus. So this changed as I h cross by 2m dou square psi by dou x square. Here multiply numerator by I, also the denominator by I. Here you put I into v psi. Here I into I square is equal to minus 1. So minus I by h cross v into psi. This is the value of dou psi by dou t. Take the complex conjugate. Complex conjugate means just you have to change the sign of I. If it is plus I, that should be changed as minus I. If it is minus I, it should be changed as plus I, and psi is replaced by psi star. So dou psi star by dou t is the complex conjugate of dou psi by dou t, that is equal to minus I h cross by 2m dou square psi star by dou x square plus I by h cross v psi star. This is the value of dou psi star by dou t. Now we have to put these values in equation 1. Dou psi by dou t and dou psi star by dou t values are to be substituted in equation 1. Now this psi star into x, I have put this value psi star x as such. Instead of dou psi by dou t, I have substituted these values, plus then dou psi star by dou t this much into xi dx. Just I have substituted the values of dou psi by dou t and dou psi star by dou t in equation 1. See here take out I h cross by 2m outside. The rest of the terms are psi star x dou square psi by dou x square minus of this term. Just we have taken out I h cross by 2m outside, so minus of dou square psi star by dou x square into this term. But see here, minus I by h cross v psi into psi star x plus I by h cross v psi star into x psi. These two terms are cancelled out. These two terms are cancelled out. This into this is expressed in minus. This into this is expressed in plus. So these two terms are cancelled out. So that psi star x, I have taken out I h cross by 2m outside. So psi star x dou square psi by dou x square. Here I have taken out I h cross by 2m. This negative sign is maintained. So minus dou square psi star by dou x square into this quantity x psi. Entire is multiplied by dx. These two terms are cancelled out because one is in negative and another one is in positive. Then the operator dou square by dou x square is Hermitian, which means that the operator dou square by dou x square is a Hermitian one. Therefore, it satisfies this condition. Say f star dou square g by dou x square into dx equal to g into dou square f star by dou x square into dx. This is a condition for Hermitian. Suppose the operator dou square by dou x square is Hermitian, it should satisfy this condition. Consider an integral f star dou square by dou x square into g into dx equal to, take this g, then g into dou square f star by dou x square into dx. If the operator is Hermitian, this condition should be satisfied. A Hermitian operator should satisfy this condition. Say f star dou square by dou x square into g into dx equal to g into dou square by dou x square into f star dx. Now consider this second term, dou square psi star by dou x square x psi into dx. This integral is taken. Integral dou square psi star by dou x square into x psi. This integral is taken. If this operator dou square by dou x square is Hermitian, this is equal to psi star into dou square by dou x square of x psi. This formula, I have used this formula. Say psi star into dou square by dou x square into x psi dx. Now this is modified as psi star into dou by dou x of x psi into dx, because dou square by dou x square is dou by dou x into dou by dou x. Just I have taken out dou by dou x outside, so rest of the things are dou by dou x into x psi into dx. Here we have to use uv formula. This is u, this is v. So psi star into dou by dou x, this is dou x by dou x equal to 1, so psi alone be present, plus keep x as a constant, x into dou psi by dou x into dx. Once again allow this operator to allow on this. This is psi star into dou psi by dou x, then dou by dou x of uv formula we have to adopt. If you allow this dou by dou x to operate on x, dou x by dou x is 1, so dou psi by dou x, plus keep x as a constant. Allow this dou by dou x to operate on dou psi by dou x, you can get dou square psi by dou x square. Entire is multiplied by dx. Now psi star dou psi by dou x plus psi star dou psi by dou x plus psi star x into dou square psi by dou x square entire is multiplied by dx. This is, if you combine these two terms, we can get, these two terms are combined, we can get 2 psi star dou psi by dou x plus psi star x into dou square psi by dou x square entire is multiplied by dx. This is the value of this integral. Now we have to substitute this value in equation 5. d by dt of this IH cross by 2m, this term is present as such, psi star x dou square psi by dou x square minus of the integral value of this term is this one, 2 psi star dou psi by dou x minus psi star x dou square psi by dou x square into dx. See here, these two terms are identical, so they are cancelled out. So the value of d by dt of expectation of x equal to IH cross by 2m minus 2 psi star dou psi by dou x into dx. Here 2 get cancelled, 1 by 2m, bring this IH cross inside the integral. See, we can cancel this much, bring this 1 by m outside, this IH cross is taken inside the integral, psi star with a negative sign minus IH cross dou by dou x psi into dx. This is our px, because p equal to minus IH cross delta x component of momentum px equal to minus IH cross dou by dou x. This is x component of momentum. So psi star px psi into dx, this is px, psi star px into psi into dx is the value of d by dt of expectation of x. So this is replaced by expectation of px. So 1 by m into expectation of px is equal to d by dt of expectation of x. Now expectation of px, or the average value of x component of momentum, is equal to m into d by dt of x. We know that rate of change of displacement is called velocity. This is velocity. The change in position with respect to time is called velocity. So d by dt of x equal to v. So this is mvx. In classical mechanics, the value of momentum equal to the product of mass into velocity. So the average value of x component of momentum is equal to mass into velocity of component along the x-axis. So we have taken out the concept wave packet. Wave packet is associated with quantum mechanics, but we have arrived at the classical result, linear momentum, which is the product of mass into velocity. In general, expectation of momentum is equal to mass into d by dt of r. Here r equal to position vector x, y, z. So in this way, we may conclude that the Ehrenfest theorem correlates the result of quantum mechanics to classical mechanics. Both the concepts are providing the same result if you utilize average value of a dynamical operator, dynamical variable, in terms of a wave packet. That's all about Ehrenfest.